Hi, Catherine. Hi, Bianca. I'm Warren Walk with Dominion Power. I understand you want to learn a little bit more about what we do and about public damage.
Yes. What is public damage?
Public damage is when a person causes a power outage. It might be as far as a car hitting a utility pole, or somebody digging in their backyard hit an underground cable, or even vandalism.
So if there's public damage to a power line, it's your job to fix it.
Exactly. We have crews that will go out and restore service to the customer. Come on, let me show you some things. Do you know how power gets to your neighborhood?
Yes. We know that it is transmitted from the power plant to our homes.
Exactly. When the generator spins in the power plant, the voltage comes out at about 230,000 volts.
Isn't that a lot higher voltage than what is used in our homes?
Absolutely.
Then why does it have to be such high voltage at the power plant?
Electricity travels much easier over long distances at a higher voltage. The high voltage electricity travels through wires that string all across the area. Eventually, these high voltage power lines go into a fenced off area full of large metal boxes, fat wires, and other stuff. These areas are called substations. In a substation, the very high voltage electricity is changed into lower voltage electricity. Even though the voltage is lower, it is still too high for you to use in your home.
Is there another place where the voltage is even lower?
That's right, there is. It's in your neighborhood. If you look up on the power pole, you'll see a round gray, looks like a can. That's a transformer. They're called transformers because they transform the electricity to just the right voltage for your home. In other neighborhoods, the wires are underground. In that case, the transformer is a big green box.
What is the voltage used for our homes?
Eventually, the voltage is stepped down to 240 volts for your large appliances. That would be like your air conditioner and your clothes dryer. And then 120 volts, and that would run like your hair dryer or your microwave or your toaster.
Is there a way that we can measure how much energy is used in our homes?
Yes, there's a meter on the side of your house called a kilowatt hour meter.
What is a kilowatt hour?
A kilowatt hour is a measurement of energy. Kilo means 1,000, so that's 1,000 watts, a kilowatt. A toaster is a 1 kilowatt device. If it were running for 1 hour, it would use a kilowatt hour of energy. You can figure out how much energy an appliance will use. You just take the rating of the appliance in kilowatts, the time it is on continuously, and multiply it. If a microwave used 1 kilowatt of power per hour for 3 hours, that would equal 3 kilowatt hours.
If we had a 3 kilowatt device that ran for 1 hour, would it be the same amount of energy?
Yes, it would, and you can also figure out how much it would cost to run that appliance.
How do we do that?
Ask your parents to show you your utility bill. On the bill, it'll show what you're being charged per kilowatt hour. For example, let's say the charge per kilowatt hour is 5 cents. We have a toaster, a hairdryer, and a microwave. We'll say that each of these appliances is a 1 kilowatt device. How much would it cost to run these appliances for 2 hours?
Well, a 1 kilowatt appliance running for 2 hours would equal 2 kilowatt hours of energy. If there were 3 appliances, that would be a total of 6 kilowatt hours.
Right, so find the price. We would multiply kilowatt hours times the cents per kilowatt hour. That's 6 kilowatt hours times 5 cents per kilowatt hour, or 30 cents. And so by using a little math, you can calculate what each appliance in your home will cost to run.
You can learn more about calculating energy costs at the NASA Wi-Fi's website. Thanks for telling us about it.
Hey, look over there. I wonder what that person's painting on the grass.
Oh, that's Mr. Utility. He provides a service to locate underground cable for people. Why don't you ask him about his job?
Great, we'll do that. Thanks for telling us what you do, Mr. Walk.
Sure, I'll see you later.
Bye.
Bye-bye.
Hi, kids.
Hi, can we ask what are you doing?
Sure, I'm marking lines on this property to let everyone know that there's an underground power line buried there. The homeowners had called us up because they're planning on putting in a fence. They were afraid they were damaged some underground utilities.
I wonder what would happen if someone was putting up a fence and they didn't call you.
That could be a problem. Someone can easily damage an underground utility simply because they didn't know it was there.
Would that be considered public damage?
Yes, it sure would.
But Mr. E doesn't have any painted lines in his yard, and he just finished putting up a fence, and his house is without power.
I don't remember seeing any lines in his yard either.
Let me check my list. No, I don't see a Mr. E on my list, and you say he's without power?
Yes, in fact, several houses are without power.
Jim to repair crew.
This is a repair crew. Go ahead.
We've got a homeowner here who has put in a fence. He didn't contact us. I think we got a power break here.
Maybe there's public damage to the underground line.
We've had a report of an outage to several houses. We'll check it out. Thank you.
Hey, kids, what's happening?
Mr. E, did you call Mr. Utility to find out where your underground power lines were before you started putting up your fence?
What do you mean?
Mr. E, you should have called us. I could have easily shown you where the underground power line was, and you could have prevented this power outage.
Oh, man, if I'd have known I was supposed to call you, I would have.
Doesn't Mr. E look kind of familiar?
Hey, man, next time I promise to give you a call, okay?
Mr. E, my crews will make repairs and we'll get the lights back on. See you later, Treehouse Detectives.
Bye!